In this video, we will learn how to link the equipment SCADA source tag to the equipment signal or to the driver out tag. So to make the example very easily, in my data, I will insert two internal tags. And the first one will be called CB open, and we have CB close. So they are integer, and default value is 0. Okay. So most of the time from the equipment for the breaker position, we have 2 bits. So we have CB close and we have CB open. So the table value, the true table of this breaker position will be if CB close is 1 and CB open is 0, then the breaker is closed. If CB open is 1 and CB close is 0, then the breaker is open. If CB close and CB open, they are both equal to 0, then the position is intermediate. If both signals are 1, then we have a fault, since we cannot have a breaker open and close at the same time. So how to link these two signals to my substation breaker 1 position? First, in breaker position, let's check what we have in SCADA. So in SCADA now, we don't have any tag, and we can use default conversion. So we have default conversion, and we don't have any tag. So we have to link this tag, source tag, to my 2-bit signal. How to proceed? We have to combine these two signals together. So I can just make a wait of this one close, and then this is my bit number 1, and bit number 0, I will just add the other one. So I will write data CB open. So this one will be my LSB, and this one is my LSB. Most significant bit, and no, less significant bit and most significant bit here. Then here I take the absolute value. I don't want to have any negative value. So the equation would be similar with this one. Okay. So now my 2 bits are combined together. So also I can insert here power. Here I can write display here. I can write display also here, and I will link this to display. I will link the value to the CB open value, and this one will link to CB close value. So you can choose the display, or you can choose the set point. If you want to modify a display, you can still do it. You just change the property isSetPoint to true, and then it's the same if you just insert the set point here. Okay, so we can also copy and paste the link, copy and paste the link. So these two displays will have the same effect. Okay, then I will choose in my breaker position. Now the active sources operator, I will change to SCADA, and I can run my project. So now the breaker is open. So here we have CB open, CB close. So what I can do is I can just write beside what is it about. So CB open here. and we have CB up close just under. Okay, so now I can run and I can make a simulation. If I change here, we don't have any impact on the breaker. So you may have also this problem. The reason is because the link here must be bidirectional. So you have to check carefully if the link here is bidirectional. Then if I change here, I can change the value. But let's check the logic. If the breaker is closed, as here we have intermediate, and if it's 2-1, this is fault, and here we don't have exactly what we want. The reason is because the system will take as a true table this one, but our device say otherwise. Open is 1, close is 2, intermediate is 0, and invalid is 3. So here we can change, or we can also call a new conversion for the device name, for example. So this is my new conversion table. So now the system will also take this, but we can input this value, and automatically the system will take these 2 and convert to 1 everywhere in the system for this unique device by default. So now we can just start again. So now this is invalid, so the correct color. Then we have open, then we have invalid again, then we have close, and then we have fault. So now it's working properly. This is how you can link the breaker position here with 2 single bits just by this way, and also apply the correct conversion to make it work.